Alright guys, welcome to another video. This guy is following the formation of ions video. This one is about how once we understand what ions are, what happens to them once they lose or gain electrons. So that's what we spoke about in the last video, that ions are atoms that have either lost or gained electrons so that they have full outer shells and that they're stable and happy. And that ions, when they form, they can either be negative ions or they can be positive ions. And we said that metals form positive ions because they lose electrons, and non-metals form negative ions because they gain electrons. So the purpose of this video is to show what happens when those ions form and how they actually come together and they form compounds and what that looks like. So if you haven't watched the formation of ions video, go back and watch that one before this. Alright, so we're going to again start with, I'm going to show you how we form an ionic compound now, and we're going to use, just for consistency and because it's easy, we're going to use sodium, because that's what we've used so many times before, and my pen has decided to stop working. Alright, so we're back. Alright, so we're going to start with sodium. Sodium is Na, and we know that the sodium atom, I'm not going to reteach this, but we know that sodium atom has one valence electron in its outer shell. So this is a neutral sodium atom, right? So this one electron is sitting there. Remember, we know that atoms don't like to have unfilled full outer. They like to have full outer shells, and so at the moment sodium is it's unstable. And we're going to react that sodium. React means let them collide, right? For a reaction to occur, we'd actually physically need one atom to collide with another. And so in this case, we're going to react it with a chlorine atom. All right, we'll make chlorine blue so that we can sort of keep track. Now, chlorine is a halogen, and that means it's in group 7. So it actually has 7 valence electrons. Just like that. So we've got sodium, which is a metal. Good to remember. And we've got chlorine, which is a non-metal, ready to react. And these guys at the moment are neutral atoms. They have the same number of protons and electrons. They haven't lost or gained any yet, but we're going to let them do that, right? So when they collide, we know that sodium would love, if possible, to get rid of this electron. If he can, if something will take it off him, he'll have a full outer shell, the one underneath, and he'll be stable, he'll be in his happy place. We also know that chlorine is missing one electron, and if he could gain one more, he would have 8, and he would have a full outer shell. And that's what's going to happen. So this is the form. We've got 2 neutral atoms here. Let's label those neutral atoms. And when that electron is transferred, the electron is transferred from the sodium atom to the chlorine, the sodium loses the electron and the chlorine gains it. And what we have is we form our ions. So sodium no longer has that electron, so he forms a positive cation. And chlorine, having gained an extra electron, he has his original ones, but he's also gained one electron from sodium, forms he's now got an extra electron that he had before. He's got one more electron than in his nucleus that the protons have. So he's got one extra electron than a proton, so he's actually got a negative charge. So what we've formed here is that the electron has been transferred from the sodium to the chlorine, and we've formed ions. Now this is sort of a revision of the previous video, and we know that sodium or metals form cations because they're positive. And we know that the non-metals, like chlorine, form anions because they form negative charges. So we've got these ions. Now the focus of this video is, well, what happens next? We've got this ion, this positive ion, this sodium, and we've got this negative chloride ion. We call it an iodine now, so chloride. What happens next? Now I want you to think. In the real world, in your life, I think you'll know that if you take a magnet, right, and you take one magnet and you put the positive end of one magnet next to the negative end of another, what happens? Yeah, those magnets, they actually attract each other, right? So what we know is that positive things attract negative things. And so when we've got I'm going to simplify it over here, when we've got a positive sodium ion that's formed and a negative chloride ion that's formed, we now have two particles, one's positive and one's negative, right? They're ions, and so they actually attract each other. They form what we call a bond. Sort of like, you know, if you guys, one day you might have the privilege of getting married, and when you guys get married, you form a bond, and that bond is forever, and you stick together, and you love on each other. This is nothing like that, but it's apart from the fact that it forms a bond, right? So this bond means it acts as a unit now. This sodium and this chloride ion are stuck together, and they've actually formed a bond, and we call it an ionic bond. And it's called an ionic bond because it's formed between ions, right? So it's formed between ions. So that's an ionic bond, and that bond is held together because of the positive charge and the negative charge of these ions attracting each other, and we call that electrostatic attraction. Electrostatic. Electro, difference in, you know, electrical charges, static, standing still. So electrical or electrostatic attraction, and that forms an ionic compound. It's a compound because it has two or more, in this case two, different elements bonded together. That's what makes it a compound. It's an ionic compound because those things that are bonded are ions. They have charges. So that forms an ionic compound. And in this case, that ionic compound has the formula of NaCl. That's what a chemist would write. And this is called sodium chloride. Or another, you know, it's table salt, right? Right? That's what you guys put on your steaks when it's a little bit, you know, you need a little bit of taste. It adds flavour. Sodium chloride. This is table salt, which is really cool. Also really cool to remember that. No, we won't go there. So yeah, so that's table salt. Now the last thing I want to do in this video is just to highlight the fact that when this, you know, when ions are formed like this and sodium and chloride form these ions, it's very rare that one sodium ion will form and one chloride ion will form. A lot of the time in the real world, we're talking about millions of these ions forming all at once. Because if you think of table salt, you have that white crystal structure, right? And that white crystal structure is millions of these sodiums and millions of these chlorides all bonded together to form this compound called sodium chloride. So this is like the simplest way to draw it. But if we were to zoom in on a crystal, what you'll actually see is, I'm going to try and draw it, what you actually would see is that the crystal would have positive sodium bonded to a negative chloride, just like above, but then there would be another positive sodium bonded to that same negative, right? So they can actually bond. Because of the electrostatic charges, we form lots of bonds. And then we'd have a chloride ion bonded to that, and so forth. And we actually start to form like a crystal lattice, they call it, right? So it's like a crystal. It's like a big ladder. But this ladder is 3D, right? So we can even go back into the page. I'm a terrible drawer, but let's try it. But what you'll notice is as we draw this, wherever we've got a positive ion, it's bonded to a negative ion. And you'll see here that this positive ion is actually bonded to 1, 2, 3. And if I could draw another one, 4, 5, there's about 6. If I drew them all in, that they bond together each, and it makes these compounds really, really strong. And so that's why that's what this is here is really the crystal structure, ionic crystal. So it's just a lot of these individual units up here bonded together into this structure. But you'll notice that the formula for this crystal is we don't write, you know, 1 million NAs bonded to 1 million CLs. We just write NaCl because that formula there tells us the simplest ratio that these sodiums and these chlorides exist in this crystal. So for every one sodium I've got, for every one positive ion, I've got one negative. Okay, even though I've got lots of them, the ratio, the relationship is one of these to one of these. And so the formula stays as sodium chloride. But it's really important to remember that ionic compounds, which is what this is, are crystals, and they can be as big or as small as you want, depending on how many ions you got. They just keep building and building and building. They'll just keep growing and growing and growing and growing. You can have different ionic crystals, but they always have a metal and a non-metal. So I hope that's made a little bit of sense. That's an ionic compound. That's the beginnings of how we write formulae and that sort of stuff. Next video, I'll probably practice some of this sort of stuff and just show you that it can get a little bit more complicated than one cation with one anion. There's multiple things that can go on there. But hope that video has been helpful, and see you soon.